Morning, everyone. I'm your moderator for this session for New Technology Shines on Solar Development. My name is Drake Becksted. I am the Contracts Administrator as well as the Operations and Maintenance Administrator for Interconnection Systems out of Central City. Today we have a panel of multiple people to talk about the new technology. From AES we have Mike Simpson, and from Ranger Power we have Alexandra Boillot and Eric Myers. I will let them introduce themselves further when they begin presenting, and I will let them take it away now. Mike, please.
So Mike Simpson, I am the director of our innovation engineering team at AES. I lead a small group of engineers who's really focused on taking new technologies and building them into our project pipeline, really all for the purposes of AES as an independent power producer. So we do have a few small utilities, but we also primarily our business is in selling kilowatt hours, delivering that power cost effectively, practically. And so we've got an engineering team focused on developing new projects. I'm part of AES Clean Energy, which is focused on primarily renewable projects, solar, wind, energy storage. And my group sits alongside of that engineering team to make sure that, again, we're bringing in the right kinds of products to meet the needs of those plants. But really the end goal of all of that is to make sure that we operate these plants over the long duration. So we try to take into account all the needs of operation. We're not just building projects to flip them. I got to AES kind of a circuitous path, started in research. I was working with lithium-ion batteries about 17 years ago, originally in some other applications, but have been doing that for grid applications for about 15 years. And came back to AES actually just a few months ago, but was here previously, and bring a lot of background in research as well as some commercial development of utility scale projects to help develop some of these technologies. So I'll try to remember everything that was in my slides. Like I said, AES operates in, I believe, 15 countries. We've got a broad portfolio. Historically, the company was based heavily in coal and natural gas, but we have been transitioning a lot of that over to renewables in the last decade or so, and now it's certainly our biggest growth area. I guess I'll just throw out a couple of provoking topics today. Hopefully, take everything with a grain of salt. Hopefully, it's not too far out there, but at the same time, I'm trying to figure out where we're going next. And I think the topic of this conversation is to try to identify some of those ideas. So I'll welcome any concerned or curious faces, and certainly any questions on the topic. But what I wanted to talk about today was what we're starting to see in the application of solar, specifically as solar adoption rises to a point where this hits on the earlier conversation about interconnection. It's really changing the way we're thinking about how these projects deliver services to the grid. So if I remember correctly, I think one of my slides showed the progression. I tend to think about solar as originally starting out as delivering energy, producing energy. And then the next kind of phase in solar was providing power at the right times. When you were with the ability to add storage, you could change the services provided by solar energy, delivering it at certain times, certain capacities. And now what we're seeing as solar and storage becomes much more common is the interest in providing grid stability with these systems, which wasn't previously there. And so I was thinking about the shift from production really to energy shifting, and then eventually to leading the energy or providing stability overall on the grid. We're seeing this in a couple of niche areas, right? We've got about 5 years of operating history on solar and storage, and we've been both DC coupled and AC coupled. Some of the early projects that we had done out in Hawaii, where there's a little bit more unique cases when it comes to grid integration, have shown that using the ability to take these inverter-based resources and actually control the entire grid with them is something that's quite feasible. And normally, for the last several years, it's been sort of this niche case. But over the past couple of years, we've seen that grow a lot, not just with growing interest in microgrids, but in general from a lot of the different utilities that we work with, a lot of the different partners that we have. We're seeing more and more interest in actually contracted projects in primarily grid forming applications. So, well, now it's loud. And I wanted to bring up that topic for discussion today because as we get to more and more renewables, right, more and more inverter-based resources, the amount of spinning inertia on the grid is potentially declining depending on how that's addressed. There are a couple of ways where we could maintain spinning inertia. But obviously, there's no question that we need to maintain grid reliability and in fact, hopefully enhance grid reliability. And we're seeing that in a couple of places that are operating 100% renewables, at least for certain times of the day, certain times of the year right now. But we're also seeing that being more and more of interest as the study of using inverter-based resources for grid forming applications grows. We're seeing a lot more research into the types of controls and the blending of those controls applied in real-world scenarios. And so I'd like to entertain that for discussion today. And thanks for bearing with the technical hurdles here. Look forward to your questions and engagement.
As Drake mentioned, I'm Eric Myers. I'm here with Alexandra Boillot, and we are both with Ranger Power. Ranger is a developer who was founded in 2017, and we've primarily been focused in the upper Midwest. We've got about 1.9 gigawatts of successful projects, and we've got about a gigawatt of that under construction right now, or moving into operation. Wanted to talk to you today a little bit about how the technology for solar has evolved, and Al's going to get into that a little bit more. But really, both the efficiency and the cost effectiveness of solar have changed dramatically over time. The other thing that we have spent a lot of time focusing on, I think it's something that's important to the way we approach development, is we've improved the way we interact with stakeholders in the community. We've come up with different ways of building our projects and in working through the permitting process, and I think those are equal platforms for innovation. I think we've got to find ways to integrate ourselves into the community, both physically and electrically. I focus on transmission interconnection, which is a whole nother ball of wax, and you guys just got done listening to a presentation on that, but wanted to turn it over to Al, and she's going to explain to you some of the innovations we've seen in solar panel technology in the last decade.
Thank you, Eric. Can everyone hear me okay? So as Eric mentioned, I'm going to talk through a couple of the main technology features that we're seeing in utility scale solar projects. And improvements that we've already seen and improvements that we're expecting to continue to come. So first, I wanted to talk through and highlight the difference between a bifacial and a monofacial panel. Bifacial panels are what are currently used in, I would say, most utility scale solar projects. And the difference here, and you'll see this in the graph on the right side of the slide, is really that they're actually photovoltaic modules on both sides of the panel so that you're able to generate additional energy that is coming from the reflection from the ground. And so this graph shows kind of the average gain that you can get from using a bifacial panel. You'll see roughly 6 to 12% depending on the month. And one interesting thing to highlight is that actually in the months where there is potential for snow cover, you're getting more gain because snow is more reflective than grass. And then this just shows we model just the same representative solar project, 100 megawatts in Nebraska, using a bifacial panel and a monofacial panel, just to see the difference in the energy that you can actually produce in a year from that project. The next piece of technology is tracking systems. So at this point, most utility scale solar projects are using what is called a horizontal single axis tracking system versus a fixed tilt tracking. And so with the horizontal single axis tracking, you actually have the modules moving, the panels moving throughout the day, tracking the sun, so that at all times you're basically being as efficient as possible and getting the maximum amount of sunlight. And one thing also that we're currently seeing right now in terms of advancing technology with tracking, companies like Nevados are actually making it so that you can use tracking systems on not just flat land, but with land that have higher slope grading. So traditionally, solar has looked for flat land so that you minimize shading and you can get the maximum amount of sunlight throughout the day. And companies are now looking into developing technology that will allow you to build on land with higher slope grading. So this company, Nevados, they currently are able to work with slopes up to 37%. So that's a huge advancement and something that we expect to see more of in the coming years. So this is, again, just showing the difference between the same representative Nebraska solar project, difference that you can get from using fixed tilt versus single axis tracking system. And you'll see this is quite a large difference in terms of the amount of energy that's produced in a year. And then the last thing I'll quickly talk through is the increased module efficiency. So with improvements in technology over the past several years, we've actually seen the wattage of the modules used go up quite a bit. So a few years ago, utility scale solar projects were using modules that were about 330 watts. And today we are up to 540 watts and greater. And so that's something that we expect to see, grow even in the coming years. And so while this can't necessarily increase your nameplate capacity because you're constrained there with how much you can actually inject onto the grid at any one point of time, it does increase the overall efficiency of the project and also the cost efficiency, because if you have more efficient panels, you don't need as many of them, which is obviously a huge cost of solar projects, is actually buying the panels. And so if you can use fewer panels to get the same amount of energy, then obviously that's increasing the cost effectiveness. It also increases just the overall efficiency, and so you can use less acres to get the same amount of megawatts. And so this next graph, this shows over the past couple of years, there's 2017 model, 2022, and then estimated for 2027, what the module efficiency is, but also what is the land needed for a 100 megawatt project. And this is just the land area projected for that 100 megawatt project. And then I'm going to pass it over to Eric, who's going to talk a little bit more about module efficiency.
Thanks, Al. So the trend's great. We're seeing an increase in module efficiency that translates to lower construction costs per unit of energy produced, lower levelized cost of energy. These are positive trends for us to see. And where that comes from, and I just love this chart because I hate this chart, but it violates every rule of making charts that anyone's ever written. But the people at NRL are brilliant. And again, this is just a deeper dive into all the things driving that upward trend that we're seeing in efficiency. This is essentially all the different chemistries that are being explored, all the different technologies that are being explored, and the efficiency gains we've been seeing since 1975. Not everybody on this panel was around in 1975, but I can tell you it's a great year. We've seen really, really positive trends in the efficiency of panels. The yellow line is kind of where we are, where most of the panels are being, is what most panels are built from right now, crystalline silicon. But I guess the good news is nice positive trend with crystalline silicon, but there are other technologies out there that have been making more substantial leaps and bounds in the last decade. But all this innovation, and I want to go back to a point that Mike made earlier, we like to see more benefits coming from solar technology. We like to see these innovations occurring. But we do have a bottleneck, and that bottleneck is the interconnection process. And so, where I spend a lot of my time is trying to find ways to make the projects that we propose for interconnection as boring as possible. Because, to comments that were made on an earlier panel, one of the ways of speeding up the interconnection study process is to have rules of thumb and sort of thresholds that we study for, and not looking at the specific benefits or differences of each individual project, because that just takes time and scarce engineering resources. So, Just a couple things I'll point out here, and this has not been updated for the 2022 Q position, which showed that really sort of asymptotic growth that we saw in the last presentation. But not all the projects that get proposed make it through the queue, and that's just a truism. And it does take a long time to get through the queue. So you're seeing a lag process. This sort of pale yellow / peach line that's sort of ticking along the bottom. Those are the projects that are coming online each year. And as you see, it's lagging these large spikes in what shows up in the queue. The other point that I'd like to make on this, and this goes back to the slide that was presented earlier on the breakdown of the 2020 queue filings, you saw this big stack on top of two bars, or two layers of that last bar that were roughly equal. And what you were seeing there was storage and hybrid. Now there's likely quite a bit of double counting in these storage and hybrid stacks. And the reason that is because those of us who've been filing queue positions have been finding out that storage as a feature doesn't always model as well as storage standalone or as solar standalone. So what we've seen as a queue strategy evolving is that people who are filing these hybrid positions are also filing a separate standalone solar position just in case that model is better. And so I think that presents yet another sort of technology opportunity for us but that is a technology, both an opportunity and a risk for innovation is how do we study these projects and how do we look at their impacts to the grid and how do we do that in a rational way that doesn't just stick us in a long conversation but can move these projects through the queue and also stimulate more innovation, because nobody wants to be the first that hangs up in the queue or gets assigned a bunch of unreasonable costs because the modelers just don't know how to model it. And so with that, I think we'd all be really happy to take your questions.
Well, thank you all for those presentations. Definitely a lot of information there to digest, for sure, especially that particular graph. Before we start with a few Q&A, I thought I had a few thoughts myself, obviously preparing for this moderation as well as listening to your presentations. And the topic of the tech and interconnection and integration. I think one thing that a lot of people in this world that we live in with renewables are currently discussing internally as well as externally is the impact of the Inflation Reduction Act. So in tandem with that, do any of you see that prompting further acceleration of technology integration as well as the interconnection question, or do we see a steady as she goes sort of plane as we continue forward into the mid-2020s here?
I'll take a first cut and then let's see what the panelists have to say. I think that during the wind panel there was some sort of oblique references made to the fact that the IRA is going to drive innovation. And I think it's because it's given us a slightly more complicated problem to solve, because there are all these sort of geographic incentives that are layered on top of where's the best wind regime, or where's the best point of interconnection. And so when you've got those other sort of itches to scratch economically, that causes you to either develop in areas that might have not been as ripe for development in terms of the amount of solar that's there, or the amount of wind that's there. And that also might cause you to look for technologies that help you capture more of that IRA-driven value. So I don't know, Mike or Al, if you had other thoughts on that.
Yeah, I mean, maybe I'll just build on that. I think maybe another angle is simply the fact that making these kinds of projects more lucrative for the companies developing and owning them is going to mean more scale. And I've been in several conversations, and I like to talk about the fancy new technologies, but the sexiest thing about some of this stuff is that it works, right? And if we can get it to work, we can get the scale to grow, and that's honestly going to bring in more of the incentives provided by the IRA to begin with. So I think, and the name of the game is clearly grow and scale right now. If we're going to solve some of the issues that need to be addressed by these technologies, we got to do it at a much larger scale. So, I think that's the most exciting part, is just making it work.
Excellent, thank you. So with that, and I'll turn it over to the floor here for everybody else who has questions. Another thing that came into my mind is we've seen a good progression of BESS, battery energy storage, becoming the tandem for how we're going to continue innovation with the new efficiencies and technology. So is that something that we look at for continued support of the grid, especially when we're discussing areas that are starting to go to 100% renewable generation instead of hybrids of legacy and renewables? Or are we, as Mike alluded to, going to continue to see more focus on the technology we have, we know that works? I mean, just getting your perspective on that.
I mean, personally, I think energy storage. I've worked in energy storage for a while, and I think that it holds a lot of promise. It's an enabler, I think, of a lot of other technologies. I mean, solar is one of them. It does a good job at that. I'd love to see a future, a bit of a crazy idea, but I personally think that storage is a bit of a Band-Aid, and there could be a future scenario where we don't need as much storage as we think we need right now, but it's necessary to get to that future scenario, and will help address some of the congestion, some of the other transmission issues that we're seeing in bringing on renewables, especially with solar. And I think I'm not sure exactly what the expected year that we hit this in Nebraska is, but certainly in California, it's been a few years since the duck curve has become a reality, right? Where it's almost impossible to bring on new solar unless you have storage with it. And so it's fortunately storage is becoming more plain vanilla. It's not quite there yet. And we need to mature that technology, really productize it in order to scale it to meet the growth of solar. But I think it's getting there, and I think that I guess the takeaway is that it's a necessity for now, and looking forward to bringing a lot more of it online.
Yeah, I think with storage, and I mentioned one thing before, which is it does complicate the interconnection study process as compared to a standalone solar project. And sometimes there are offsetting benefits that overcome that complication in the interconnection study process. I also think that there are a lot of things that storage can do that are already being provided by assets that have yet to retire. So a lot of that inertial support or reactive power is a need that the long-term studies know exists. But because there are already assets on the system right now providing those, the market for providing that as a separate service and for capturing the value of that benefit that batteries provide has not quite evolved. And because of that, the price signal that creates that additional benefit for, and that additional incentive for the market to demand storage and for developers to include storage in their proposal is not as mature as the technology itself. And I guess the last thing I would say is, in general, I don't think there are a lot of developers that are looking to take technology risks. So, we are looking to deploy technologies that are tested, and storage in most cases is meeting that threshold. So that's very positive. But I do think we've got a lot of way to come balancing that sort of the complexity of a deal and what can you monetize. The complexity on the side of the interconnection study can really be a negative. You want to be as simple, as boring as you possibly can, and sort of skate through the interconnection process that you can. Mm-hmm. And on the flip side is, if you can't do that first thing, then there needs to be a solid market to sell all those extra things that are not just energy that battery can provide. The market needs to appreciate those benefits.
Excellent. Thank you for your answers. And with that, I will turn it over to the floor. Does anybody have a question for our panelists?
With the growth of solar in the Midwest, what's the future of agrivoltaics? Is it viable for large-scale solar?
It's evolving. I think that when you look at the sort of the marginal cost of energy and its comparison to other sources of generation, it's a pretty competitive business right now. And so I think that one of the benefits of this improving efficiency will be to create more room for more complex projects, including projects that integrate agrivoltaics. It can be as simple as bringing in goats to do some of your vegetation management, all the way up to intercropping. One of the interesting things about when you put arrays further and further north is because where the sun is on the horizon, they tend to be spaced a little further apart so they don't shade each other. And so that might create even more opportunity as the rows between panels get wider. Then your opportunities for doing intercropped agriculture become greater. All that goes back to complexity is not always what project developers are looking for, and having another active land use on the site does create complexity from the standpoint of development and from the standpoint of safety and just managing what's taking place on the site. So I'd say it's early days, but I do think there's a tremendous amount of opportunity.
I would also add that, yeah, I think there's a lot of opportunity here, and it's something that's being studied, I think, very actively right now. In the past couple of weeks, I've seen numerous articles on, studying the effects of agrivoltaics and also looking at what crops are the most efficient with it. And so I think there will be a lot more that we learn over the next couple of years as some of these studies continue to move on. But one article that I did see this morning was actually talking about a study specifically on tomato crops, and how this one study had actually seen that tomato crops are enhanced when they are placed with solar panels. So, I think there's a lot more research to be done, but I think there's definitely opportunity.
Maybe a few statements to add on. That, vegetation under panels can be a problem, but certainly also a benefit in this case. In addition to the ground coverage ratio and the space between the rows, we're also seeing higher trackers. So single-axis trackers have certainly been in and out of favor over the past decade, 15 years, and they seem to have now squarely seated themselves as a sound option, and in many cases as a preference that we use, certainly going into large-scale sites. So as we see, sort of the two-up trackers with two parallel rows of modules, they need to be at 7-8 feet in height anyway, and so you've got room not just between the rows but also under the modules to be doing this. It's proven to be useful in several of our sites, and I think that we'll continue to see growth there. It's just like anything, it's heavily regionally dependent, and so it should be another tool in the toolbox of the many others that we as land becomes more and more scarce. The dual use of land, I think, will become really important. But we got to identify where the best regions are, and the studies that Alexandra just mentioned, I think, are going to be really useful as they approach finality in the next couple of years, understanding what the true value of it is.
Just one other point, just getting back to, Mike mentioned height. That is one of the factors that we're managing for that sort of intersects with the suitability of agrivoltaics. If we're going to create space for grazing or for some other compatible agricultural land uses, height will be a factor. And right now, what we're trying to do is keep them as low on the horizon as we possibly can to manage visual impact. So one of the trade-offs for integrating agrivoltaics may be to raise the height of our arrays.
So what does the domestic content and the Build Back Better and meeting federal fundings that's now going to be available, and how does the domestic manufacturing structure, how is it positioned to respond to all of those challenges?
I would say that there's an awful lot of rulemaking that has to take place before we know how quickly we're going to be able to incorporate and pursue some of these domestic content goals. But I think it's a positive trend. It's nice to be part of an industry that is trending towards its future growth being more intensely driven by domestic content and domestic manufacturing and domestic jobs. But we know from other industries that have gone through this experience that the proof is in the rule set, and we'll be watching very closely to see how that evolves. We don't want to see confusion and disruption in the supply chain slowing down what we've seen in a really healthy growth rate in the deployment of new arrays.
I think my mind maybe kicked into gear. Thank you for for the jolt there. Yeah, just to build on that, the domestic supply is something that we're hearing a lot of our suppliers start to shift into that mindset of really taking another look, maybe of many looks, maybe of the first look, at what the profitability is that they can reach by bringing manufacturing onshore. Specifically, I think the logistics, the cost of logistics, the delays of logistics over the last 3 years have made that, have really flipped the picture to where it warrants a new look, and then the incentives are bringing even more interest there. So we're pretty hopeful that, I think we're actually seeing a lot of positive progress towards our suppliers establishing that manufacturing locally. to enable not just our U.S. projects, but also around the globe. Hopefully we'll have more in another few months as those rules settle out, as Eric said.
All right, so we asked what is happening with Ranger Power regarding engaging with rules on community solar. And I'm assuming within the state of Nebraska, of course, is part of that focus.
Well, unfortunately, neither Alexandra nor I are Lone Rangers here today, so I'd be happy to pitch to my colleague Ollie Chag. He's actually front and center or back and center. Maybe we could get Ollie a mic.
Sir, thank you for the question. So we obviously work with both the city of Lincoln and so high level we're working on what's called the Salt Creek Solar Farm. It's just east of here. It's still in development. And we're actively working with the city of Lincoln as well as Lancaster County to get everything up to speed and all permits as well. So I'd be happy to speak with you about this after and specific to Salt Creek. But obviously we're in compliance with everything on a high level.
Speaking more broadly, though, we see the siting of each project to learn more about what works for landowners and learn more strategies for engaging with landowners and with county, local, municipal governments. We're also learning, what sort of ordinances work best, and we get involved in those conversations as those ordinances are being considered, where there may not be zoning right now. You like to think as a developer the best site would be one that didn't have a lot of stipulated zoning ordinances, but we're learning more. It's better to have a rule set in many cases than to go into it not knowing and to get a rule set laid on top of your project, 2 or 3 years in. So we're being very proactive in talking to landowners about what they want to see, and when those conversations crop up with county and local governments, we engage actively. We're not dragging our heels. We'd rather see a regime that works than wonder what's going to get layered on later.
And I would just add that, this community first approach, I would say, is really core to Ranger's overall mission and how we develop projects. We really care about becoming part of the community and learning how we can help to benefit the community. We're not just trying to go in and kind of steamroll a solar project through the permitting process or, through construction. We really do want to gather feedback from our landowners, from abutters, from county commissioners, from everyone, and see how we can work best with that county, because we're obviously making a very long-term investment partnership with each community that we're in, and we want to make sure that we can be good stakeholders in that community throughout the project duration.
All right, thank you for your answers. Anybody else? We'll wrap up the panel here in just a second. Anybody else have anything else?
Can you maybe speak a little bit towards maybe any automation or robotics research, if there's anything there that's being done, whether it's Ranger or AES, just on-site in operations or even in the development and construction side of projects?
I'll jump in. I think one of the key avenues to the scaling that I've been trying to harp on is certainly automation and robotics. There are a lot of opportunities to this from a data processing point of view. There's so much that we need to glean from our operating sites now as we try to scale quickly. We do have a lot of, the industry, not just AES, has a lot of sites in operation, terabytes and terabytes worth of data that can be mined for valuable lessons. So that's certainly a piece, maybe a more obvious piece. We're also looking at ways to automate the deployment of these sites. So anything from modular prefab arrays full of modules and the structure required that can be essentially rolled out on site. I think, on the order of a couple megawatts a day. We've got with some of the technologies that we're deploying right now, as well as literally robots that go around, pick and place modules onto the arrays. There's still a need for a lot of manual labor on these sites, but that can accelerate some of the time frame and focus more on the higher skilled labor jobs at those sites. And then once they're in operation, like I said, I think there's a lot to do that we're gleaning from machine learning, from just basic enhancement of even more manually operated tools so that we can process more data, derive the insights from that amount of data that's growing exponentially right now.
And scale's the magic ingredient. If you're just one project and the next one's not for 500 miles or 5 years, then optimizing and deploying these sort of optimization technologies like robotics aren't as attractive. But as the industry scales, I think we're going to see more deployment.
All right. Well, thank you everyone for time listening today. Thank you for our panel members. And if you have any questions, of course, you can find them here while we attend the conference.